Hi, I'm Bartosz Filipek, the architect within the QA team in BC Financial Technologies, and this is my friend Szymon.
Hi, I'm Szymon, his friend, and I also work with him. This is my architect, and I'm a senior software engineer in QA team in BC. If you don't know what is BC, BC is a Danish fintech company, which is a diamond sponsor of this conference. So we can look it out, search on the internet, or go to our stand right next to the door there to know better our company. And if you're wondering why we two IT technical guys came here on this stage today, is because we have very important message to you guys. This is a very important message also for us. We are not perfect, best public speakers, but we'll try our best to share with this message with you also. Because we with Bartosz, we think that we as a QA, we need to be louder. Why? Why we need to be louder? Because QAs are people who, when they are in company, often they are only people who know that there is something really wrong going on in the company. Sometimes they are only ones who know that. That's why very often they should be louder. And this is the main reason why Jurassic Park project actually failed. So?
Yeah, so before we will go and take you on this astonishing adventure with us, I have one question. Have you seen the Jurassic Park movie already?
Who hasn't seen it? Can raise the hand. Hasn't.
Hasn't. Okay. Anyone?
Okay, we have
at least one person.
two people, I think.
Okay. So there will be a spoiler alert because we have some plot within the presentation. So if you are very interested into watching the movie, you can, I don't know, maybe close your eyes, hide your ears, at least at the beginning, right? Because we will take you for a short adventure.
Yes, exactly. So why we are talking about Jurassic Park? Because you came to the QA conference, and first we tell you you should be louder. Now we are talking about Jurassic Park. What is going on, right? So let me explain. We people from IT, we love cool, modern projects. Yes, we can agree on that one probably. So actually, it happens that Jurassic Park was a project not far different from the IT projects that we are working in right now. Let me show you. Jurassic Park had very nice electric modern cars, whole infrastructure of cars that should take people around the island to see dinosaurs. It had astonishing buildings built, fresh, brand new ones. They had also IT infrastructure. You can see it on the next picture. And they had a lot of the best scientists, and many of them, like big IT companies right now. And also they had great, looking very nice, and from the first sight perfect security infrastructure. So you can see that it had very nice products, building beautiful infrastructure and products. Yeah, but beside of those nice products, they had also long list of risks. And since we're talking about risks,
yeah, did you know that actually within the Jurassic Park movie, within the whole cool stuff, they had also QAs. Actually, those guys were not always counted as a real QAs, right? Because we can differentiate a couple of types of the people that cared about the quality within the Jurassic Park itself. Actually, there was some stuff that it's worth to take a look. Because, for example, we had the lawyer that was representing the customers. He was caring about the quality from some perspective, but at the end of the day, he was caring mostly about the money. So the return of the investment was the most important for him. And actually, I don't know if you, among those that have seen the movie, can figure it out who was the real QA in the Jurassic Park. Anyone?
Who?
Yeah, there was this guy, the warden.
Do you remember?
So at least one person can recognize such a guy, right? But he was not loud enough. He was pointing out to some failures, to the security, safety problems, but at the end, we know that there was some guy eaten by the raptor, for example. But who cares, right? The money are a bit more interesting.
Yes, exactly. And what Bartosz is talking about right now is actually a situation when you have in one project people who they think that they represent money, the business, on the one side, and we have people representing the quality, and those people are from the same team. Okay, they are caring about the same goal. They're trying to achieve the same goal, but they are on a different opposite sides here. Why is that? Because there is a problem with communication here. Because money thinks that they care about, the business thinks that they care about money, and the quality is trying to care about something else. Which fault is this? Whose fault is this in this situation? It's not only business fault, let me tell you. It's also fault of quality. Because quality represents the QA mindset, and quality QA responsibility is to make a business understand that quality cares about money. Okay, that's important to emphasize. So with this situation, what went wrong in Jurassic Park, how it ended? I hope that at this point you would like to see the development team in Jurassic Park. Okay, are you excited? Do you want to see it?
The whole team.
Okay, so this is the team. One guy writing all the code. I wonder who was doing the code review for him. Probably himself. Yeah, probably himself, right? Yeah, so in IT, we did our lesson and we call such situations dependency bottleneck, because you cannot afford the situation when the whole project, the whole project depends on one guy. Yes, and this guy didn't understand it as well, because he was clearly bragging that he can do a lot of things by himself, right? And he was bragging that he's so fast and doing the stuff. So he totally misunderstood the concept of the automation, let me tell you. But apart from him, there were different other scientists, really good scientists. Let me tell you, this is Samuel Jackson. This is a very good scientist. But the thing that they were lacking, those scientists, was the QA mindset. Because when they saw item 151 on the today's glitch list, it didn't make them reflect if this is a good idea to do production testing. Okay?
Yeah, and despite the fact that Warden was actually pointing out to some things that are wrong going on, the list of the glitch is actually the CEO was not even fully aware what is going on within the coolest project of the times, right? So he figured out that maybe it's worth to, I don't know, take his grandkids for the production testing. So the user acceptance with the own grandkids is a perfect idea, right?
Good test.
What can go wrong?
Yeah.
Seamlessly. And actually, this pressure of the success was ignoring all the risks that are actually popping up, right? And do you know what happened next once they got into those cars and went?
Yeah. everything just broke down, despite all this cool technology. So do you want to see what happened to this beautiful products and technology that they were building? Yeah, first of all, the electric cars. They were very modern because they were electric, taking people around, but once the electricity went out, they couldn't even escape the dinosaurs using those cars. And remember the astonishing buildings? Dinosaurs had a different plan for them. And about the security fences and security infrastructure, it couldn't hold those dangerous dinosaurs, and even the security infrastructure just broke down and deal.
Yeah, and actually that moves us a bit to the situation in which they had the emergency button, but they've never checked if it's working. So the failover seemed, maybe it was in the minds, but no one actually ever checked if it's working.
Yeah, and since we are showing you the similarities with Jurassic Park project, I wonder how many of you think that they worked in a Jurassic Park like that, some company that worked as a Jurassic Park, or maybe you even work in such company right now. I won't ask you to raise hands, but you can think about it, how it's similar to your situation. And maybe you remember when you joined the company and you were hoping for the best, to see beautiful processes and how they are building the best quality products. But instead, you saw all the reasons that actually they were hiring for. And probably your face was similar to face of this guy from Jurassic Park. Yeah, that's most likely the reaction once you see it. Because maybe you saw that they are actually having in the company such dangerous dinosaurs, but they have similar faces like those people. They are excited about them, so they are not seeing the risks. Yes, they only see the value of the product, and it might look like some pattern, right?
Yeah, that actually brought us to the reflection that we know very similar pattern that is commonly used nowadays within the IT companies. It's called the DDD. So you may know it is dinosaur driven development. And actually, we've recognized that we faced very similar thing, and we've ended in the mainframe COBOL Park with a lot of actually dangerous COBOL programs surrounding us, right? And we actually entered. Why not? What can go wrong, like in this production, right? Within the Jurassic Park. So that's how we started the journey.
Yeah, we started the journey. We entered the Cobble Park and we started to look around. And we wanted to understand how, what was the history? What were the decisions? What is the history of this company and the decisions? And actually we traced back what happened, and we ended up 60 years ago in this history when first decision was made, because on the market there was no tool available to buy. So somebody decided to build it in-house, custom tool. But with customization, it's the case that if you once go on the path of customization, you need to bring the new customization on top of existing customization. Okay, so you build customizations one on top of another because you are not capable to integrate them with market standard tools very often. And once company does that, once a company goes to the customization path, it's very hard to turn back to the market standard tools path. We did very detailed analysis, and this is example analysis of a case of COBOL program, and there were several, maybe many even of them. It had 135,000 lines of code after compilation. This is one program. It was using 300 data structures, 500 sections. Sections are like functions, or it divides code into methods, some sections. It was created in 1984, and that's why nobody in the team knew how it works, because it was lacking documentation and it was lacking the test cases. Because if they had unit testing, they would have regression testing, they would have documentation, right? You know that. It would have code coverage and low-level requirements validation. Okay, that's why they missed all of it, because they were not introducing unit testing. And let me speak for a moment about the test environment that we had. Test environment consists, in our case, mostly in DB2. It's a database, and we have the beautiful, dangerous COBOL programs as well. And those COBOL programs are talking to each other. They are dependent on each other, and the COBOL programs are developed in different teams quite often, although having dependency. So it makes some situations hard, especially when some team decides to change something, introduce new version of a program. And those programs were using very often the same table, although being in different domains and so on. That's why at this point, if you see it, you can tell that the test environment was just unstable. So even if they wanted to introduce tests, like integration testing, it was really hard, because look at a situation in team 6. They introduced test case 3, let's say. But since team 3 is making a change in the program and team 2 is changing the data in the database, it makes a result of this test just unpredictable. Yeah, it can be a success, false positive, different other results. So you cannot count on the result of such tests, unfortunately. Oh, and see, new dinosaur was born. New COBOL program was developed. So this problem was just growing, and we were afraid of the situation. So after analysis, we noted down all the constraints and all the problems. So we saw that we have no stable test environment, that we have no unit testing tool for COBOL, that we are lacking documentation, and we have no test process defined, and that there was no way to run functional tests. So we had to make a decision with Bartosz.
Yeah, actually, we were in a better place, better position than the warden. Actually, we've realized that we have to do something with that, right? And we had the capabilities to do so. So actually, we started to test a bit, not to get eaten like the warden did, because at the end he was consumed by a couple of raptors, actually. So not nice thing. And we started a bit with the risk mitigation, with the reflection on the mentioned already stuff. And one of the things, the key things that we started was actually the PRA. So I guess you know PRA, right? At least some of you, I hope so. But as we with Szymon, we are not the best in the processes. We are better a bit in the processors, so we focus mostly on the development stuff. And we started with the unit testing. So that was our first key goal, to actually secure the foundations.
Yes, this was the point that we wanted to start with, unit testing for COBOL. And this is how BCAT tool was born. This is the logo of this tool. It stands for BC unit testing. And how the idea of this was born. We started to observe how COBOL developers are working and how they're trying to test. And we observed that they are going to the IBM mainframe debugger to debug the program, to stop in some places, change variable values, then stop in different place and check the variable value. So they were actually manually testing the program. If you want to see how the debugger looks on the mainframe, it looks like that.
Do you know La Gazzetta?
Yeah, if you were checking the weather or the program on Itala Gazeta, it's similar. It doesn't have a lot of space here. It's a little bit crowded, but it shares. It has a lot of functionalities. You can, for example, put comments here in text and automate some breakpoints and stuff. And that's what the developers of COBOL were doing, actually. They were stopping, changing the values, checking the values, and so on. So we noticed that maybe we can automate that. We can base our tool on this workflow. And that's how BCAT is working. So you have developer on the start, and this developer is creating a test case. And then this developer can run the test case on local machine or in a CI/CD pipeline. BCAT is a Java library, and I will explain why it's Java in a second, but it's producing the test scripts, sending them to the mainframe. And on the mainframe part, the execution begins in the debugging mode. And the debugger is automated thanks to the scripts and performing the test logic this way. Then the log is produced and we retrieve the log. The BCAT is getting the log and seeing what happened there and if it was the expected thing to happen. And since BCAT is a Java library, thankfully, you don't have to know Java very well to write the test cases because the syntax is very easy. So it's not very hard for COBOL developers to start testing. But thanks to the fact that this is Java library, you can, for example, add cool stuff to it, like Cucumber, and start BDD testing. And you can add Jenkins to it and automate it in CI/CD pipeline. You can add Allure or other reporting tools. This is just an example. And since you are running that in CI/CD, you can do the SonarQube analysis, maybe a report to X-ray, so integrate with modern market standard tools. So we've noticed that we not only developed Java library, which is a unit testing framework for COBOL, but it's actually a bridge. It's a bridge between mainframe world and market standard tools for COBOL developers. Let me quickly cover the features of this testing tool. It has a very interesting feature of mocks generation by recording. So you can just start the program and generate the mocks automatically. I wonder if there is a way to do it in Java, because in Java you need to provide the mocks manually, and here you can just run the program and record everything. 135,000 lines of code can be recorded.
Yeah, so you can imagine that it's the plain text of 135,000 lines.
Yeah, a lot of variables there, let me tell you. You can write then the test cases, test sections, which I told you about, variables, calls, what calls happen during the program execution. So it's actually giving COBOL developers everything to test in the COBOL program there is. And also we are a little proud about one feature that was developed because since we could debug the program, COBOL program, we've noticed that we can monitor everything. So we can build graphs like this one, which is explaining to people who are onboarding on a project, COBOL project, for the first time, seeing this big old COBOL program from the past. They need to change something, they are scared. So they can run this process and build a graph for this program and see what other programs it's calling, what are the sections, what are the relationships between the sections, and what happens in individual section. And let me emphasize that this is not only static analysis, it's in runtime analysis in the runtime. So if you run different use case for the program, you will get different graph. And you can hover over the mouse on the arrow and see what kind of lines were executed, and you don't see here lines that weren't executed. So it helps people to understand what the program was doing. But that wasn't enough, right, Bartosz?
Yeah, so I have two questions to you guys. One, do know any couple stuff, the aware of data structures, stuff like that, a couple of sound groups. Yeah, we didn't do. And actually, do you think based on that, is it enough? We did the same because this guy was the, let's say, COBOL programmer, so he was left alone. No one else knew how it works, right? And we realized that the unit testing coverage is not enough because despite the fact that he was developing the stuff, he was partially unit testing, right? His failure during the sabotage was ultimate, and he couldn't even predict that it was not fully working within the system integration. So actually, what we missed, we've realized that we have a couple of manual testers on board. We have multiple BAs on the board, but like within the movie, right? They had the manual override. They had this guy with the manual rifle, but we needed someone with the automatic rifle for the functional automated tests. And the next step was to introduce somehow possibilities to interact within the system with the COBOL programs, which is not easy. And we've actually went further on, and we've developed a tool that is called Test Data Factory. And the huge advantage for the tool itself is that it's speaking the common standard way that is quite well known. It was the REST API with the JSONs, right? So that helped us actually to solve also the problem of the agnostic, right? Because we had different teams, different problems. We had the UI guys, we had the backend guys. Combining that, this point wasn't easy, but actually we've developed the external service that is available for the Jenkins, for the TypeScript, for the Java, for Python. So any kind of library, any kind of way for the test automation. And from the first glance, it's quite easy because it's, let's say, translating the input, which is in JSON, to the legacy system. At the end is the bytes, it's the plain text consumed by the COBOL programs, that it fits the something that is called actually the copybooks. Now, nice name. And it looks simple, but at the end of the day, it isn't actually, because it's doing some other stuff than the simple serialization and deserialization. So it's not only changing the JSON to the bytecode, right? And we went further on. What is actually needed? As a QA within the development team, I would be glad to have the ability to both execute my test locally on my computer, which is fast and mostly efficient, right? Plus, I want to actually validate what my colleagues, developers are doing, and I want to integrate that with the CI/CD pipeline. So actually, thanks to those REST APIs with the JSON stuff, we are able to call the application that is deployed on the OpenShift in our case, and it's actually integrated within the Bitbucket. So it's our Git, which we have those copybooks, COBOL programs, and we can actually validate the content that is sent out from outside and be sure that it's perfect, it's good enough to send it as a byte and process on the mainframe. Yeah, but we've realized that it's worth to have also the response, right? So the process goes in the same way, but backward. So we are taking some responses, some information from the mainframe. We are translating it once more and sending back to the end user with some response. I love those 200 responses. Yeah. not always happening.
Yeah, beautiful. We need to finish, unfortunately, slowly. But at the end, we would like to have one reflection about this whole situation that we had with Bartosz, and also that we observed during watching the Jurassic Park, and to share what is the real problem in projects in general. The problem was that people that weren't even QAs realized it wasn't too early to realize for them that they are having quality issues. Okay, when it was too late, they realized that only they had an illusion of control, because they had those shiny, beautiful products, those cars, dinosaurs, which are very cool and so on. But it's just because it's so shiny, it's giving just an illusion that you have quality, because it's all shiny, and they weren't seeing all the issues with quality. And there was this one warden who noticed that, but he was only one, and people, QAs in companies are often in the minority, so the situation is just similar, and they are only ones, and you might be the only one who notices in your company this illusion of control. And because you are in my minority, it means that you need to be louder. And if you handle it very nice, very good, you can make the business realize that cost is maybe more important than quality, but quality is the best way actually to reduce costs. So we hope that that will be inspiring for you. And we would like to thank you for your that you listen to us. And actually, we can test, right? If you can be loud, and maybe you want to ask some questions. Oh, there's one.
Yeah, thank you. For starters, I wanted to say that was the longest period someone haven't mentioned AI, and for this, I love it. Second, you're selling knowledge and these ideas. I also love it. So my understanding is that you were into an environment with really low quality process or no quality process whatsoever. You described the idea and the tools you've introduced, which is great. Now I'm curious, how do you sell this idea? Because one thing is tools, but there are people with some sort of workflow and routines, and you have to disrupt it, change it, teach them new things. Did you have to deal with this?
So actually, we have, let's say, two approaches. We have this carrot approach, and there is a group of people that is very interested in the quality. They, especially among the common developers, they are sometimes facing those huge classes, COBOL programs, right? And once they have to refactor it, it's a nightmare for them, right? Because you can change the puzzle here and break everything else around. And there comes also the other side of the coin that we have, as we are in the financial sector. We have the audit team that is forcing people also to secure the code, right?
So it helps.
So yeah, it helps in some cases, especially with the older people, because as you have seen those programs later for a couple of years, and some people are going on the retirement and they don't want to actually learn anything new, right? But yeah, those people are partially forced, but I'm not saying that all of them, right? Among those older people, there are still persons that are very interested in the new things, and they want to actually make it better.
And let me add to what Bartosz is saying, because actually I didn't notice that, but after a few years of doing this job, after doing the workshops for the teams about these tools and so on, and you had to convince people from the team why it's worth to use it, why it's worth to learn something new sometimes, that level. And one COBOL developer shared with me a reflection that we are very good at selling. So actually, we were learning how to sell. Sometimes you had to learn how to sell, how to show the value, and I will think that maybe it's a QA job, yeah, to show the value of caring about quality, and that's what we had to do on this team level. So we had to go sometimes, spend time with the team, do the demo, and do the presentations for the domain or something. So we had to spread the news and the knowledge.
Yeah,
as
but
well.
I actually forgot about one extra thing that we have within our team. We have very loud POs. And
It helps.
he's
It
doing
helps.
also a lot of loud stuff around. Thank you.
We hope it's answering the question. Any more questions? Oh, we have one more.
I assume that when you came to the project, you don't have an idea or didn't know that you will develop such a tools. So my question is, how much time it took from the idea to the first implementation?
It's a very good question. We had several developers, and not many of them. We are QA team, so we don't have a lot of workforce. So it took like I'm in this team like nearly 5 years. Bartosz is like 4 years, and it took like 2 years to fully build and spread this test data factory tool.
Actually, we've started with some things and we were reviewing the ideas that we had, right? Because it was, let's say, the green field, because there was nothing that would help us. We couldn't use anything that is standard solution from the IBM, but actually they have some things that were at that time and still they don't have sufficiently good things, actually, especially for the couple. So I got a feeling that it's very probably not care about the quality, maybe.
And writing the code was not the longest task, right?
Yeah.
The analysis, looking
Yeah.
around, checking how we should implement the features and so on. The thinking part was, and actually selling it was the main task to do, and it took like several years, to accomplish everything.
The analysis was the longest, like, so
Yeah.
keeping on that,
But we were a small development team, so it's
what we've done.
okay. No more questions, right? So, oh,
Okay.
one more.
Yeah, so you have mentioned that you had these development teams that sometimes don't want to learn new stuff. What about the management? Because like I see the part that you presented to them some tools. Of course, tools cost something. It costs time and money, of course. And was it hard to convince the management team to do it? 'Cause I imagine the situation they tell you like, do it manually. We don't need this fancy stuff, right?
Łukasz, was it hard?
Yeah,
So this part of the job was done by our
manager.
the head of QA within the company. So he did it, right? So
A lot of convincing, probably, right? And but
Right, it's,
audits help for sure. So a lot of selling here needs to be done, and managers, of course, helps because if managers realize it and try to push the team in this direction, it helps a lot. So if you have a good manager who is trying to help that, you'll make it. It will make your way easier. Yeah, for sure.
Yeah.
But we are still struggling, yes, in some situations. With some teams, of course, you need to sell it and show them the real value, convince them that you are on the same side as them. Yeah. Thank you, guys. Thank you for
you.
your attention.